Hello and welcome to the after break session. While you digest your meals, in the next 25 minutes I'm going to build a CSS-only slideshow with a fixed aspect ratio of 16:9 with animated slide changes and some stuff more. And in the 10 minutes that follow I will try to reduce the size to exactly 1024 bytes. When I proposed this talk, I did not know if I would succeed, but well, in half an hour you'll know. The story behind this talk is this. In 2011, at my former company, I gave an internal presentation about HTML5 and CSS3, which were quite new then. And I thought I'd build a slideshow using these features so I could demonstrate what CSS was capable of then. It had rounded corners, color gradients, animated slides, but it did not have a fixed aspect ratio, nor did the slides scale with the viewport. And then 3 months ago, I rediscovered what I did then, and I thought, hey, maybe with how CSS evolved since then, it's now possible. And this is what I did. I'll go through these steps: aspect ratio in CSS, filling the viewport, scaling the content, navigation without JavaScript, visual goodies, and then the fun part, speed run through minification. You may ask, why would we do this? Why not use PowerPoint or Keynote or Reveal.js? Well, most of my talks are about web technology, and what better way to talk about web technology than to demonstrate it? And how would I include CSS within PowerPoint? I could do this with Reveal, and Reveal is a very fine tool. It's perfectly suited and it has a nice environment, but it requires JavaScript. And though I don't have anything against JavaScript, my favorite language, I tried to find out how far can CSS go, and why use JavaScript for styling if CSS can do the same. Aspect ratio in CSS. Aspect ratio in CSS means I have an element with a width, and I want to have the height of the element following a certain aspect ratio. We would like to do something like this. The width of a slide is 100%, as wide as possible, and the height is 100% divided by 16 multiplied by 9 to get an aspect ratio of 16:9. But this does not work because percentages in CSS mostly relate to the same property of the parent element. So if I set the font size to 120%, it means 120% of the font size of the parent element. If I set the width to 50%, it means 50% of the width of the containing block, parent element. And if I set the height to something related to in percent, it means percent of the height of the parent element. I cannot set the height in relation to the width. Well, I can with a hack. And the hack uses part of the specification of CSS regarding what percentage means for the padding property. The percentage is calculated with respect to the width of the generated box's containing block, even for padding top and padding bottom. Short padding top in percent means percent of the width of the containing block. So we do this. I have a slide with no content. I added some dark gray borders so you can see the slide. And I add a pseudo element. The content property is needed for the browser to display the pseudo element. The float is needed for not to mess with line heights or something like that. And then I set the padding bottom of this pseudo element to 100% divided by 16 multiplied by 9. And this green block is this pseudo element. Now, since we floated this element, the containing slide does not include it in its inner height because floating elements are taken from the height calculation. But we can fix this. The simplest way is by setting overflow hidden to the parent element, and now the slide has exactly an aspect ratio of 16:9. We are not yet done. We need an element within the slide, which we have to position absolutely to cover the complete slide. Because if I did not have this element within, if the content of the slide would exceed the height, the slide would get bigger. But with this inner element, which has exactly the dimensions of the slide with the aspect ratio of 16:9, I can set overflow auto to this inner element, and if the content of this inner element exceeds the size, I get a scroll bar. Why do we need this except for a slideshow? Well, if I have an image, the browser does not know how big this image is until it's downloaded. So if I set the width of the image in dependency of the in respect to the element it is contained in, then I don't know the height, and as soon as the browser downloads the image, it gets rendered and the content below jumps down. If I set a placeholder on the right side, nothing has to jump down when the image is loaded. If I know the aspect ratio, and normally I do, I can set this placeholder with this fixed aspect ratio and then the image inside, so when the image is loaded, nothing has to be recalculated. So now we have a way to get an element with a fixed aspect ratio. Unfortunately, for our use case, this hack does not work, because we only have the possibility to set the height of an element in respect to the width. But if the height of the viewport is not high enough for the content of the slide for my aspect ratio, I would have to set the width of the slide in relation to the height. And there's no property for a hack like this to set the width of an element in respect to its height. But there is help. We have this VW and VH units. VW stands for viewport width and VH for viewport height. And with these units, I can scale elements in relation to the viewport. This green rectangle at the top corner has a width of 10 VW and a height of 10 VH. So if I scale the viewport, this element scales with it. And these units we can use to build a slide that fits into the viewport. Let's start with the viewport with an aspect ratio of exactly 16:9. Then we would have to scale the slide to 100 view width and 100 viewport height. Now what happens if the viewport gets wider, so the aspect ratio is larger? Then the limiting dimension of the viewport is the height. We still set the height of the slide to 100 VH, but we have to calculate the width from the height by dividing by 9, multiplying with 16. And the other way around is the viewport is smaller than 16:9, then the width is the limiting dimension, and we have to calculate the height from the width. So this is the CSS we need. We have an interesting media query, which is called min aspect ratio. I can react to the aspect ratio of the viewport. That's very nice. And so I set the dimensions of the slide to 100 VW and calculate the height from this. But if the aspect ratio is at least 16:9, I do it the other way around. Set it to the height of 100 VH and calculate the width. Now we want to scale the content of the slide. If you look at this image, you see the slide is scaled to fit the viewport. But these labels 100 VW and 100 VH, or the calculation, remains the same size. We would need something like this. We set the font size to 5% of the height of the slide, but I guess you are not surprised if I tell you this is not possible as well. Because percentages means, in this case, the percentage of the property of the parent element. But there is a fix. It's called rem, root em. Em is the font size of the parent element, and rem is the font size of the root element, the HTML element itself. And this is a unit I can use for everything. And so I can define the width and the height and the font size and margins and paddings in rem. So if I find a solution to set the rem so that I can scale everything properly, then I can scale the content of each slide. Basically, I set the font size of the HTML element to 5VH. This is a font size, I think it's fairly good readable, as you can see, because this is 5VH. And then I set the height of the slide to 20 rem. 20 rem, if 1 rem is 5VH, is 100 VH, which is what we had before. And I calculate the width from the height. Of course, I have to do something different. If the aspect ratio is bigger than 16:9, then I have to, no, it's smaller. The example before was for 16:9. I have to calculate the font size from the VW unit. Those two calculations, those two values at an aspect ratio of exactly 16:9 are the same. So I have this font size trick on the root element, and I calculate the size of the slide from it, and then I can use this rem unit for everything within the slide, and the content scales with the viewport, as you can see. Now we have everything technical we need for a slideshow, and the slideshow I'm going to build now, I thought long about what the content should be, and I sat down with my significant other and I came up with this little poem. To you I profess, the way to success is found in the power of CSS. This is the markup of one slide. I use the section element because section element has the advantage that I can use the H1 heading inside and I don't have to look what is outside. So in other words, the section element is something like a document within the document. And this is what I have. If I have a slideshow, I want to display one slide at a time, and I can think of what I display at a time as the document I'm displaying. This is the complete HTML. You don't have to be able to read it. It's basically the CSS I showed and the markup for the 3 slides. It's 855 bytes, so we have plenty of space to add some features. The most important thing is navigation without JavaScript. How would I do that? How can I display one slide and hide the others? Well, the answer is the target selector. The target selector is a pseudo class in CSS, and it selects this element with the ID of the hash part of the location. So if I have a location and the hash part is changelog, and I have an element with the ID of changelog, with the target selector, I can target this element and set the color to hot pink or something like that. And in case of the slideshow, I use this to hide every element that has not the target pseudo class. I set the visibility to hidden, but I could have as well set display to none. But I choose visibility because visibility can be animated and display cannot. If I try to animate display to none, as soon as the animation starts, the none value is applied. While when I animate visibility to hidden, the hidden state is applied at the end of the animation. So now I need an ID for every slide. And this ID I can use to navigate to the next slide. If I add an anchor element with the ID of the next slide in one slide, I can click on this anchor element. it changes the location of the hash of the location, and then by this the next element gets the pseudo class of target and it gets displayed. But if I do so, I see nothing. Where are my slides? Because I hide every slide that does not have the target pseudo class. If I don't have a hash part in the location, then no slide gets displayed. Everything is hidden. How could I solve this? Well, the easiest way is to say, well, then I always have to provide a hash in the URL. I don't want this. This is not robust enough. I can do so with JavaScript. I could add the ID of the first slide to the location if there is no hash, but I'm building a slideshow with CSS-only, so this is not an option. And the last thing I can do is, after the last section, I add an anchor element linking to the first slide. And when I click on this anchor, I select the first slide, and it gets displayed, and so I only have to hide the anchor if there is a selected slide. And this I do by the CSS below. If there is a targeted section before the anchor element, I set it to display none. The tilde selector says it must be a sibling, but comes before. So A is a sibling after any section. With this, we are at 1,211 bytes, and this, of course, means plenty of space to add new features. Visual goodies. We want the slide not to be at the top left corner. We want the slide to be centered vertically and horizontally. This is easy because we can just set the top and the left value of the slide to half the remainder of the slide width and the viewport width. So I have the viewport width, subtract the slide width divided by 2, and this is my left value, and the same for the top value. Then I want the content of the slide to be centered as well, and we use Flexbox for this. It's quite easy. I say display flex, I say flex direction column, so the content of the slide is stacked underneath each other and not next to each other. And by saying justify content to center and align items to center, I center the content vertically and horizontally. I want an animation. This is not difficult. I set a transition CSS property to the section. I transition the transform property in 0.8 seconds, and the timing function is ease, so it's not linear, but a little better looking. And then I hide the slides that are not selected, not targeted, to scale to 0. This means scale 1 is the original size, and scale 0 is nothing, so I just shrink the slide out of the view. Then I add some colors. I add a gradient to the background, and to be able to see this background, I reduce the size of the slide slightly, so it's not a height of 20 rem, but 18 rem. And I add a black border. In total, we are at 1,595 bytes. This means, of course, still plenty of space to add new features. A keyboard navigation. Now, keyboard navigation has to be done with JavaScript, but it's okay. I have a solution that works without, and now it's just progressively enhanced to add a keyboard navigation with JavaScript. I add a key up event listener to the document, and basically if the key code is 37, which is the left arrow key, or 39, which is the right arrow key, I calculate what the number of the next slide is. I get the slide from the number of the current slide from the location, and then I add or subtract 1, and if the next ID is at least 1, then I apply it, and if it's smaller than the number of slides, we are at 2,152 bytes. Still enough space to add something. I add a counter to the slides. In the lower right corner, you can see the number of the slide, and this is done by a CSS counter. With each section, I increment the counter of the name of slide by 1, and I add a pseudo element after the section, and I display the value of this counter. And this is very simple and straightforward, and I didn't know it was so well supported in browsers until I used this at the beginning of the year. It even works in Firefox too. So now we are at 2,346 bytes, and I think now it's time to reduce this, try to reduce this to 1,024. What can we do? The most obvious part is remove leading white space. This removes 751 bytes. We are down to 1,595. How can we improve the CSS? We can combine selectors. I have two selectors which set position absolute bottom 1 rem. I can combine this to what you can see on the right side. I have one declaration block with two selectors with position absolute bottom rem, and then the declaration blocks I had before, I removed position and bottom. This saves us 12 bytes. We can combine selectors even more. I have two different ways to hide an element. Once I set visibility to hidden, and the other thing I said display none. We can combine this to hide the starting link by setting visibility hidden and transform scale to 0 as well, saving us 18 bytes. We are down at 1,565. We can remove optional whitespace. Most whitespace in CSS is optional, but not all. If you do a calculation and have a minus operator within, CSS needs the space around this minus operator. We can remove the white space around the division mark, but we cannot around the minus. Removing all optional white space saves us 59 bytes. We can improve the calculations. The first calculation is just some static calculation we can do by ourselves or with a calculator. 5 VW divided by 16 multiplied by 9 is 2.8125 VW, and to save some more bytes, I just round this to 2.8 VW. The second thing, I cannot remove the calculation completely, but I can do the division by 2 by myself. I can divide 100 by 2 and 18 by 2, leaving us with the thing on the right side. This is very handy because calculation in Android 4.4 is only supported for addition and subtraction, but not division or multiplication. So with this change, we do support Android 4.4. And the last thing, a leading 0 for a number can be omitted. So 0.1 is the same as .1. Improving all calculations saves 38 bytes. We can omit defaults. The color of the border property, if I don't set a color, the color of the font color is used. And since I did not set any font color, it's the default font color of the document, which is black, so I can leave black away. The transition function of ease is the default. If I don't set a transition function, ease will be used. So this saves us 11 bytes. I can use shorthands. Instead of setting the background color, I just set background, because I did not set anything like a background image or did not set any background other background property. I can just save 6 bytes by using background instead of background color. I can remove optional semicolons. I think you have to look really close to see the difference between the upper and the lower block. It's the last semicolon in the declaration block. I only needed a semicolon to divide declarations in a declaration block. So I can save 7 bytes because I can save 7 semicolons. In this special case, I can use EM instead of REM. rem is the font size on the root element, and em is the font size of the element. But since I did not change any font size from the root to any element, one em is the same as one rem, so I can save 8 bytes. I can shorten the counter name. I use the counter name of slide. If I say counter name s, I can save another 8 bytes because I use the counter name twice. I can shorten the colors. Instead of FFFFFF, I can just say FFF. I could have used the color red, which is the shortest color I can say set, but red is ugly. I can transition all properties instead of the transform property. I only set the change the transform property when I hide the slide. So I can say transition all and save 6 bytes. Sounds like the blues of desperation. No, this is desperation. The pseudo element selector starts with 2 colons, but for historical reasons, 1 colon still is valid. So I save 2 bytes. And then removing the line breaks of CSS, saving us 41 bytes. We are down to 1,370. Now let's try to improve the CSS. I can remove optional whitespace. Almost all whitespace in JavaScript is optional, so I can save 42 bytes. I can rename variables. Instead of next ID, I call the variable n, and instead of current ID, I call it c, so I save 111 bytes, which is the largest saving I have, except for the leading whitespace at the beginning. I can extract globals to variables. In the upper block, you can see I access the location property of the global object twice. If I extract this to a variable called L, I can save 2 bytes. I could have done something similar with document. I use document twice, but if I extract this to a variable, I end up with 1 byte more. So I use another trick, because inside the event handler function, the this keyword refers to the element the event handler was registered on. So it's the document inside, because I added the event listener to the document. So I can save 4 bytes. I can do even shorter. Instead of using add event listener to add the event listener, I just define the onKeyer property of the document, and this saves us 24 bytes. I can omit optional braces and semicolons. If a block contains only 1 statement, I can remove the curly braces. And in some cases, I can omit semicolons. Douglas Crockford will hate me. I save 13 bytes by this. I can shorten the number conversion. I get a substring of the hash part of the location and parse it to an integer with parseInt. But since I know it's just numbers, I can use the unary plus operator to convert the string to a number. This saves 12 bytes. I can use slice instead of substring. It does the same, and I do not understand why we use substring, because slice has exactly the same API, with the advantage of, if I set an adjective value, it counts from the end, which substring does not do. So I can save 4 bytes by using slice instead of substring. And then I can improve the algorithm. This is basically what we do. If the key code is 37 or 39, I add 1 or subtract 1. So the difference between 37 and 39 is 2, and the difference between -1 and +1 is 2 as well. And I can take this to my advantage, because instead of using the key code directly, I subtract 38. And now if the key code, this value is -1 or 1, this is exactly what I want, and then I can add this value to the current ID. So I have slightly improved this, but I thought, hey, how could I shorten this comparison? I want to check if k is 1 or -1. Can I do shorter? It comes to mind. No, nothing comes to mind right now. Oh yeah, I shouldn't have updated the software, I guess, yesterday. Math.apps is an idea. If I use math.apps of k, then it's 1 for 1 or -1, but this is 1 byte longer. But speaking of math, if I multiply k by itself, it's exactly 1 if k is 1 or -1. So I can say, instead of this, I can say k multiplied with k equals 1, and this saves, I think, 7 bytes. Removing line breaks of JavaScript saves another 5 bytes, and we are down to 1,124. 100 to go. How can we improve the HTML? I can remove the charset because the charset is only taken from the browser if there is no charset set in the HTTP headers. So assuming I set an HTTP header, I can remove the meta charset element from the HTML, saving me 23 bytes. I can remove optional quotes. The quotes around the attribute values are optional in most cases. So with viewport, I can remove the quotes. With width is device width, I cannot because I have an equal sign and a minus sign, and this requires the quotes. Removing all quotes that are optional saves 14 bytes. My favorite. Remove optional text. Did you know that the opening HTML tag and the closing HTML tag are optional in most cases? As well, the opening and the closing head and the opening and closing body tags are optional as well. So I can just leave them away, and it saves me 45 bytes. I'm down to 1,042. And as the final countdown, I can save 18 bytes by removing line breaks, and I have the goal of exactly 1,024 bytes. Cool, huh? So I'll show this. You can scan this QR code to see if it works in your browser. I even tried this with Opera Mini, and it didn't look right, but it worked somehow. This is a slideshow. I did not provide a hash in the URL. All done? Okay, I'll switch to the demo. I did not provide a hash in the URL, so no slide is shown, but here at the bottom you have this start link, and if I click on it, I get to the first slide. To you I profess. I click on the link. Can you see the link in the bottom corner? Okay. The way to success is found in the power of CSS. And now you have to believe me, or those in the front rows can see it. If I use the keys instead of clicking on a link, I can navigate through the slides as well. Okay, I used the resulting HTML and put it through the HTML validator of the W3C, and as you can see, document checking completed, no errors or warning to show. Ha! I even took the contained CSS and put it through a CSS validator, and it's valid CSS. I took the JavaScript and put it through a JavaScript validator, and it's valid JavaScript. And I took the JavaScript and put it through ESLint, and it's no, many errors. Now, if you have a keen eye and counted the characters I showed you, you came to the result of 1,022 characters. Yes, that's true, it's 1,022 characters, because this character is not in the ASCII range of Unicode, so this character needs 2 bytes. And since I use this character twice, I come to a complete size of 1,024 bytes. Of course, you may ask, what is this presentation tool I used to present how to build a presentation tool? And of course, I used this presentation tool I built to present you this presentation. And you may ask, what was these the demos of the viewport scaling, and it was an iframe embedded in this presentation tool, including the step of the presentation I was building. I made a project of it. If you want, you can look at GitHub and use this, and you can use this tool a little fancier than what I showed in more than 1024 bytes. So thank you for listening. I hope you had fun, and if there are any questions, I'll look if there is some question in the app. No, I don't see a question. Any questions here? There is one.
Hi. Did you use a minificator for that? No.
I did it all by hand, but funny you ask. I took the JavaScript, the original JavaScript, to Uglify.js, and from, I think the original is 465 bytes, and Uglify.js reduced this to 219 bytes, and what I did was 152. But it's okay. Well, I know something that Uglify.js does not know, because I know exactly what the value of the hash is, and so I can use a different algorithm, and Uglify.js does not know it, so it just can scramble the code a little, but it cannot improve the algorithm. So I think 219 bytes is fine, but yeah, if you do it by hand, you can do better.
Okay, thanks.
But by all means, don't do this for projects you're working on.
What are the browser requirements?
I use a lot of features. Counter, Flexbox, VW and VH units, some more. I looked it up. It works in IE from version 10 on, I think. Android 4.4, Firefox 19, Chrome 20, Safari 6. So all modern browsers and some legacy ones.
Yeah, also hi. I just realized a small problem or challenge because I scanned the QR code on my Android device and turned it to landscape, which is, of course, for a 16:9 presentation would be useful. But because of Chrome, the browser bars on top, the navigation was hidden, so I couldn't navigate to the slides.
Okay, I noticed a problem with Android as well when I checked some days ago, but I think it has something to do that the viewport height unit does not refer to the actual height of the viewport, because as soon as I scroll down, the navigation bar is hidden, and I think viewport height on Android means the height of the viewport if the navigation bar is hidden.
Yeah.
So
I think you could just do a JavaScript scroll top 0, and then I think it
yes, but then I have JavaScript.
So you already had.
Okay, but then I couldn't do it with 1024 bytes. If you think you can do better than I can, and obviously there is room for improvement, I set up a challenge at GitHub. I put there the original HTML file and my minified one. I set up a README with the rules of a contest, and if you want to have a look at if you can do better, then feel free to add a pull request. Okay, thanks for coming again, and I hope you've learned something and had fun.